Hi, my name is Xiao and I will be presenting TypeDance, creating semantic typographic logos from image through personalized generation. Semantic typographic logo is a well-known visual format often seen in advertisements. It seamlessly blends semantic imagery and typeface to represent some concept while maintaining legibility. This allows people to easily recognize both imagery and the typeface within a single visual design. Creating such beautiful semantic typographic logos requires a high level of expertise. Current methods can be divided into two categories. One is the retrieval-based method, where users input text, and the system will retrieve the most similar instance from the database. However, the performance of this method is constrained by the number of existing design materials in the database. To address this limitation, some researchers opt for the generation-based method, enabling users to provide a single text prompt to guide the generation process. This approach allows for infinite generation without constraints imposed by a limited database. The problem lies in how can we specify the typeface we want to transform, the single stroke, multi-stroke, or the whole character, and how can we precisely describe the visual aspects such as shape, color palettes, and style through just the language. Additionally, how do we specify the desired visual representation in the reference image? Overall, the drawbacks of this generation-based method is its lack of user intent authoring, which is difficult to convey through just a text prompt. So in this work, we introduce TypeDance, an authoring tool that supports a personalized design workflow and allow users to flexibly blend typeface and different granularity and specific imagery without laboriously crafting a precise text prompt. In the formative study, we obtained some generalizable design patterns through corpus analysis, which included nearly 400 real-world examples composed by different languages. We identified typeface granularity, encompassing stroke, letter, and multiletter level. We also discovered diversified typeface imagery mappings, including one-to-one, one-to-many, and many-to-one relationships. Then, we conducted interviews with experts and obtained some simulatable design workflows. Through this process, we identified challenges in conventional workflow and concerns regarding the involvement of generative AI. Following the workflow, we developed the TypeDance. It contains 5 main components. The first is ideation, where users can communicate with a large language model and obtain keywords about the design. When the user hovers over a keyword, the back-end models will provide a detailed explanation. The second component involves selection, allowing users to specify which part of the typeface and which visual representation they want to blend. In the generation component, users can select and combine prior design elements such as semantics, color, and shape extracted from the reference image, and then generate. After generation, users can evaluate their generated results and identify their position on the spectrum between typeface and imagery. For example, in this case, the generated results may resemble the imagery more closely than the typeface. To refine the generated results, users can iterate by dragging the button along the typeface imagery spectrum to select the most balanced results. Overall, TypeDance offers a comprehensive workflow, including pre-generation, generation, and post-generation stages. Instead of crafting a text prompt, TypeDance allows users to upload their own image as a reference for a more explicit intent, and then it will extract design priors from the reference image to guide the following generation process. More specifically, TypeDance extracts 3 different design priors from the reference image, allowing users to select and combine them as needed. For instance, users can preserve both semantics and the shape of the visual representation from the reference image. Additionally, TypeDance can inject the color of the visual representation into the generation process. For the same typeface, user can select different parts and granularity, leading to varied performance outcomes. With flexible selection in typeface granularity and visual representation specification, user can experiment with various mapping between the typeface and imagery. For example, TypeDance can transform each letter into a skyscraper in the image. Additionally, TypeDance supports global transformation for the multi-letters to enrich the visual representation. Users also can combine multiple concepts into a single character. To overcome common issues inherent in generative AI, such as the inability to be edited for desired results, TypeDance supports post-generation editability. If you find that the result resembles the imagery more than desired, you can drag the button to adjust and push the result towards resembling the typeface. Then you can select the result that offers the highest legibility. Through this table, we can observe that the TypeDance excels by supporting blending typeface and all granularity, including stroke, letter, and multi-letter levels. When it comes to the imagery specification, both DS Fusion and TypeDance stand out, and they support using image to assign specific visual representations. However, DS Fusion requires users to provide around 20 images for fine-tuning the model, a process takes significant computational costs and takes approximately 15 minutes. Then we conducted a user study involving 9 experts and 9 novices. We conducted 2 tests, including imitations and creation. The following image shows the generated results by the participants during the creation task. In conclusion, in this work, we take a formative study that identifies generalizable design patterns and simulatable design workflow, and then we developed a blending technique that incorporates imagery with all levels of the typeface granularity. Finally, we developed an authoring tool that integrates a comprehensive workflow, empowering creators to ideate, select, generates, evaluates, and then iterates their designs. All the code is available in the GitHub. Thank you for listening.